Welcome back to Learn With Me, Ms. Killen, here at MPB. We are in our Lesson 2 of our Unit 3, Inequalities. So let's go ahead and dive in. It says we are graphing to help solve inequalities. We are looking at A-REI.3 and A-CED1. I can use graphing plus inequalities properties to solve my inequalities. So here we go. It says a skills. If I was to graph this inequality on a number line, what would that look like? All right, so on your paper, let's go ahead and draw some number lines, and let's just go ahead and graph what we know. So here we go. I'm going to do number 1. So here's my number line. I am going to put a 0 and a positive 2. Now, you may be thinking, now, Ms. Killen, in elementary school, when we had to do the number line, we had to do 1, 2, 3, 4. Okay, that's all good and well, but for space and time, sometimes you're not going to be able to put all those numbers. As long as you show where the number is in reference to 0, it's okay just to put the 0 and 2. So here we go. Now, it says that my unknowns are larger or greater than or equal to 2. So I know that a greater than or equal to is a closed circle, and I am going to graph where all my possible x's could be, so I am going to graph to the right. Now, if I would have seen this, that is the exact same statement, it's just written differently. That's why Ms. Killen keeps saying, graph and read the meaning of the inequalities. Don't just look at how it's pointing. Because if we'd have seen this one, it was not pointing to the right where we graphed, it was pointing to the left. So we want to make sure that we are graphing the meaning and not just a point. Okay, let's do the next one. Let me get a different color. Whoop. So let's get a different color. I'm going to do blue. All right, so here's my number line. I'm going to put 0 and I'm going to put -7. Now, it says -7 is less than or equal to t. So I know that all of my possible t's are bigger than my -7. So since it's less than or equal to, that is a what type of circle? It's a closed circle. So let's go ahead and graph this. So I have a closed circle and my t's are bigger, so I am graphing that way. But Ms. Killen, that's not the way it's pointing. That is exactly what I'm talking about, guys. We want to make sure that we're graphing the meanings of these inequalities, not just points. So this was a prime example. Once we understand the meanings of these inequalities, it doesn't matter which way it points, we can graph what it means. So let's do the last one. So I'm going to get me yet a different color. Let's do purple. So I have 0 and 10. It says M is greater than 10. So I have an open circle. My m's are bigger, so I am going to the right. How does yours look? Does yours look just like mine? Make sure that we are graphing our meaning of these inequalities and not just points. All right, let's go to our next slide. It says when the endpoints, or the endpoint, is an open circle, then the number represented by the endpoint is not a part of the solution set. And we said that a solution set is a set of possible solutions. So when I have this open circle, it cannot be part of the solutions. It cannot. So then, what could we possibly make an inference about a closed circle then? So if an open circle cannot be a part, then my closed circle, it can be a part. So let's go ahead and write that. So a closed circle can be a part of the solutions. That was a good job. All right, so let's look at next. It says, what if they give us the graph of an inequality? Could we write an expression to represent the graph? So now it's really, really important that we understand the meanings of the graphs and what the inequalities mean. So let's go ahead and look. So I am looking at this number line, and I have an open circle, meaning it can't be a part of it. And then I'm graphing to the right. So I'm going to write it two ways. My x's are less than 2, or my 2 is greater than my x's. Notice I did not put a line underneath because I have an open circle. So both of these expressions mean the exact same thing of that graph. All right, let's do the bottom one. So I see I have a closed circle, so it's going to be some type of equal to. So I've got my variables, and my variables are graphed to the right. That means that my variables are greater than or equal to that 13, or 13 is less than or equal to my variables. They mean the exact same thing. They're just written two different ways. So I want us throughout this unit to make sure that we're understanding I can write the same meaning two different ways. Walk into the room or please come in the room. So it's the same thing. It's written just different ways. All right, so let's look next. It says, do not just look at signs or directions of arrows. You must be able to read what the symbol means. If a number line has a closed circle on 4, then has an arrow point towards the left, what would an inequality look like that represents this graph? So let's see. I have a closed circle, so I'm going to have some type of equal to. And then I'm pointing to the left, meaning all of my possible answers or my variables are smaller. So if I use B, which one would that be? So my unknowns are less than or equal to 4. So it would be this one right here. But Ms. Killen, what about that second one where it says 4 is bigger or equal to our unknowns? Could that possibly be it? Absolutely. This one is also the answer because they mean the same thing, just written two different ways. All right, it says to write the solution set of the graph, what would that look like? All right, so what would that look like? It's going to say that my x's, such that x's are less than or equal to 4. And this is my set notation. Okay, Ms. Killen, we've not talked about that. This is my set notation. Now we've got some new things that we're looking at. All the possible x's, such that. That's what this line means, such that. It means such that x is less than or equal to 4. That's what that algebraic sentence means. We've talked about algebraic sentences. This is a complete algebraic sentence because it means that all the possible x's have to be smaller or equal to 4. Good job. So let's look at the next one. All right. So it says when the endpoint is closed circle, the numbers represented by the endpoint can or is a part of the solution set. So we talked about having this line here, meaning it can be equal. And we've also talked about what that means. It can be a part of it. When it's open, it can go right up to the number, but it can never be a part of the number. So that was another way for us to remember closed can be a part of the solution, open cannot be a part of the solution. Let's do some practice. All right, so what we're going to do here is we're going to write inequalities or we're going to graph the inequalities. So I'm going to do this on my board. You do this on your paper, and then let's see what we got. So here we go. Number 1. So I see that I have a closed circle, so I'm going to have some type of equal to, and then I have the number 3. So I'm going to, or negative 3, so I'm going to have negative 3, and I'm going to say is greater than or equal to my unknowns, or my unknowns are less than or equal to my negative 3. Number 2, I have an open circle, so that means I'm not going to have a line. So I have my unknowns, which are going to be less than my 17, or I can say that my 17 is greater than my unknowns. So let's go ahead and graph number 3. Let's do it in green. So I'm going to show my 0 and I'm going to show my 14. I have greater than or equal to, so I know it's going to be a closed circle. And it says that my unknowns are smaller than that 14, so I'm going to graph to the left. All right, so let's look at number 4. I'm using 0 and 3. And it says that my unknowns, or m, is less than or equal to 3. So I have an open circle. And they're less than, meaning they're going to go to the right. All right. So then number 5, I have a closed circle at -4. So I can say that -4 is what? My arrow goes to the right, so my -4 is less than or equal to my unknowns. Or my unknowns are greater than or equal to -4. So then number 6 says that y is greater than 4. So I'm going to put 0 and 4. I have just a greater than symbol, so I'm going to have an open circle. And it says that my unknowns are bigger, so I'm going to graph to the right. Look at yours, look at mine and compare. Is your arrows going to the right way? Does your arrows state what your inequalities are trying to tell us? Does it say that it's equal to with a closed circle? Does it just say greater than or less than with an open circle? Do you have the way that the unknowns are compared to the number given? You have to make sure that you're graphing exactly what those inequalities are saying. All right, so here we go. If we were given this inequality, what would be the solution? All right, y is or equal to included in this solution set. So let's go ahead and write our set notation for this. So I have all of my x's such that x is less than or equal to 10. So this is my set notation. I would also put my interval notation. Now here's something new, interval, the interval where my possible answers could lie. Now it says that all of my values of my unknown are smaller or equal to 10. Where does that stop? It doesn't stop. It goes on and on and on forever. So when we said the other day what it means to say go on and on and on forever, that means that we're talking about infinity. So then if I'm going on my number line at 10 and I'm going this way, where does my number line stop? At negative infinity. So if I wrote my interval notation, I would put a parentheses at negative infinity. Okay, Ms. Killen, why are you writing a parentheses? Tell me exactly what negative infinity is. You can't, because it's a concept, not a number. So since I can't be the exact, I use a parentheses. So then it says that I go to 10. Now, can I equal 10? Yes, I can. So since I can equal 10, I use a bracket. Parentheses means it cannot equal. Bracket means it can equal. All right, so that's why or equal to is so important, because it depends on if you're using a bracket or a parentheses. So x can be a 10. It can be a 10. It can't be above 10, but it can be 10. So let's go our next. Okay, so now it's time for you to show some mastery. For questions 1 through 2, write the inequality from the graph. 3 through 4, draw the graph. So I want you or you and your table partner to do 1 through 4. Once you get done, come back to me and we'll compare. Okay, so I'm going to work on the board. You compare what you or you and your table partner did to what I do up here, and let's see what we got. So number 1 says that I have a closed circle, so I've got some kind of equal to, and it's between 3 and 4, and it's kind of in the middle. So I'm going to say it's 3.5, and my graph shows me that my unknowns are getting bigger. So 3.5, I would say, is less than or equal to my unknowns. All right, number 2, I have an open circle, so that means it cannot equal. So I'm going to say that negative 10 is going to be bigger. Why? Because my graph is going to my smaller numbers, my unknowns. Or if you like to write how the arrow is going, you can put your unknowns is less than the negative 10. All right, so number 3 says t is greater than or equal to 4. So I'm going to put 0 and 4. It is a greater than or equal to, so I have a closed circle. And then it says my unknowns are bigger, so I'm going to graph to the right. And then my last one, 19 is greater than or equal to m. So I'm going to put my 0, my 19. It does have a line, so I'm going to have a closed circle. It says 19's bigger than my unknowns. So that means all of my unknowns are smaller. So I'm going to graph to the left. Check your work, check my work. Does your arrows go the same way mine do? Do you have the exact same inequality expressions that I do? Maybe you put your variables first. Maybe you put your numbers first. As long as it says the same meaning. All right? So let's remember, or not forget, endpoints open and close, what they mean. If it's open, it can be a part of the number, or the number can be a part of the solution. If it's closed, it cannot. How to write a set of possible solutions. We looked at that set notation and interval notation. And when a number can and cannot be part of the solution set. That again goes back to that open and closed endpoint. I am so glad that you came here with me and learned our Unit 3. I'm having a great time with these inequalities. I am Miss Killen. Have a great day.